Okay, here's the last lesson for the semester. Semester 1, hopefully it's in semester 1. If that pushed back, well, we're in semester 2 now. But it's the last lesson for unit 4, chapter 7. We're going to continue with 7.6. I can solve logarithmic and exponential equations. That is the target for today. Have that written down at the beginning of your notes, please. Okay, solving more logarithmic equations, you must exponentiate both sides to solve. And you need to check your answers for extraneous solutions. So what do we mean by exponentiate? So once we get the logarithmic part isolated, which in the equation on the left, log base 2 of x minus 6 equals 5, the logarithm part is isolated. It's a log base of 2. What exponential base cancels out a logarithm base of 2? That's right, a base of 2. So if we raise each power, exponentiate both sides, that means raise each side as an exponent, then what we have now is a logarithm cancel out. Let's try that again. 2 to the log base 2 cancels out. We remember that from the other day. And we have 2 to the 5th power. 2 to the 5th power is simply 32. Now we can just add 6 to both sides. And I have x equals 38. Remember, we have to plug these answers back in to make sure we get an answer that makes sense. So I check. When I plug in for x, log base 2 of 38 minus 6, I get log base 2, does that equal 5, right? We want to know if it equals 5. Log base 2 of 32. And when we plug that in our calculator, it's 2 to the 5th power 32. I think we know what it is, but in case you forget, alpha, window, log bases, log base 2 of 32, 23, log base 2 of 32 is 5. So we can see that the log base 2 of 32 is just 5. It checks, we get 5, 5 equals 5, we're good. No extraneous solution. So 38 is our answer. Okay, let's try another one. 5 natural log of x equals 35. I can't exponentiate yet. I have to get the natural log part by itself. That means this 5 is multiplying by the natural log of x. I am going to divide both sides by 5, excuse me. And I'm going to get 35 divided by 5, which is 7. Now what base cancels out the natural log? That's e. And take e as a base on both sides. X equals e to the 7th, which we put in our calculator. E to the 7th, and we get 1096, excuse me, 0.6. 1096.6. Now, should we plug that in our calculator and check? We probably should. Let's check it. So I'm just going to put it all in my calculator. We're going to do 5 times the natural log of, and we'll just approximate it, even though I could just use the answer button, but 1096.6, and I get 35.99999, which is very close to 35. It's why is it off by a little bit? Because we rounded it. Okay, we rounded that 1096.6 instead of having a full decimal. Okay? So that's exponentiating. So, log base 5x plus log of x minus 1 equals 2. What do we do with something like this? Well, we're going to have to use our condensing properties, and when we have the same base and things are being added or subtracted, we can condense them together. So if I look, this one on the left, log base 5x plus log base, or log of 10, log base 10 of x minus 1 equals 2. That's a lot to say. We can combine that into one logarithm because they have the same base. When we're adding things with the same base, we can multiply what's inside of the logarithm. So this is really log base 10 of 5x times x minus 1 equals 2. What base is going to cancel out a log base 10? Well, a base of 10 on both sides. So we're going to exponentiate both sides using a base of 10. It cancels the logarithm out. We get 5x times x minus 1 equals 10 to the second power, which is 100. So at this point, we have to distribute and factor. We get 5x squared minus 5x equals 100. Now we're going to subtract 100 from both sides. And we get 5x squared minus 5x minus 100 equals 0. So now we remember back to our factory, we have a monomial that we can factor out here, 5. So 5 times x squared minus x minus 20. Using bottoms up, what multiplies to make negative 20 and adds to make a negative 1? Well, that would be an x minus 5 and an x plus 4. Bottoms up, we divide by a. A in this case, ignore that 5 is factored out, it's a 1x squared. So dividing by 1 is not going to change anything. And my solutions, 5 doesn't have an x by it, so it's not a 0. So it's x minus 5 and x plus 4. Plus it doesn't make sense. If I do 5 equals 0, that doesn't make sense. It wouldn't be a solution anyway. Add 5 to both sides, we get x equals 5. Subtract 4 from both sides, we get x equals negative 4. Are these both solutions though? Well, we need to check. When you check this, okay, when you check it, and you plug things in back in the original equation, log base 5 times 5 plus log base 10, excuse me, not base 5, base 10 of 5 minus 1, what do we get? Does it equal 2? So 5 times 5 is 25 plus log base 10 of 4. Remember log base 25 plus log base 4. You could plug it in the calculator if you wanted to get a number, but we can reverse it. We can condense it. We get log base 10 of 25 times 4. What does that equal? What does that equal? 25 times 4 is 100. So is 10 to the second power 100? It is. That's 2. Log base 10 of 102. Now, if you believe me, do log base 10 of 100. What do you get? We get 2. So we get that answer when it checks out. So we know that the first answer, 5, is a solution. Question is, what about negative 4? Well, for negative 4, we have to check that as well. So we do log base 5 of negative 4. I'm going to write this one in blue just so we can see the difference. Plus log base 10 of negative 4 minus 1. Does that equal 2? So we get log of negative 20 plus the log of negative 5. What's the problem here? If we take the logarithm of negative numbers, I don't think so. Okay, let's plug it in our calculator. Let's see what happens when we do log of negative 20. Log of negative 20 plus the log of negative 5. We get an error, don't we? Non-real answer. So that means this is not a solution, which means negative 4 is extraneous, and we don't count it. Okay? This is an extraneous solution. So x equals 5 is the only real solution. And now we're done. Okay. I'm going to leave log base 4 of x plus 12 plus log base 4 of x equals 3 for you guys to do on your own. Okay? So, finding the inverse functions. We did this before. Let's just do a little quick recap of it. Y equals 4 to the x. Basically, to find the inverse of an exponential function, you take the logarithm of both sides. If you want to find the inverse of a natural log function, you exponentiate both sides. So, y equals 4 to the x, and y equals natural log of x minus 5. So, what are we going to do? Well, in this case, first problem, number 1, it's an exponential equation. It's a base 4 to the x. So we're going to take the log base 4 on both sides. Before we do that, what should I do? I missed the first thing. Switch x and y in the equation. Forgot to mention that. But we already knew that one. We talked about that before. Switch x and y. Now we will take the log base 4 on both sides because we want to solve this thing for y. So when I cancel this out, I get log base 4 of x equals y. And now I found the inverse of those functions. Can I check that by graphing? Okay, when I graph it, I'm going to graph the original equation. Let's go to y equals, maybe, look at that. Go to y equals, and we're going to plug in y equals 4 to the power of x. And we're going to plug in y equals, we're going to do alpha window, we're going to do log bases of base 4 of x equals y. And we're going to graph them. I'm going to do zoom 6 because I don't know what kind of window I have here. And when I graph them, here is the picture that I get. I get this. And you know what functions are inverses if you can take the diagonal line and call this y equals x. This line y equals x. If it looks like that they are reflections over that line y equals x, then they're inverses. And you can see if I flipped over or folded that graph over that dotted line, the two graphs would fall on each other. So that's a way to check to make sure you get things correctly. Okay, you guys try this one. You're going to pause it and then turn back on when you're ready for me. Okay, so you switch x and y right off the bat. That's automatic. We're finding inverses. And this time it's a natural log. So instead of taking a log of both sides, we're going to exponentiate both sides with a base of e. On this side we have e to the x equals y minus 5 plus 5 to both sides. The inverse is e to the x plus 5. Y equals e to the 5. E to the x plus 5. So I think we've hit our target. I can solve logarithmic and exponential equations. No problem. We did read the inverse functions as well. So I think we are all set for those. So bring your notes to class with you, and we'll see you on Monday. We'll see you whenever we see you. Friday today when I'm taking it. Have a good day.